Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan from the Simple Electronics YouTube channel. This episode is sponsored by PCBWay, but more about that later. Today, we do not have any very special guests. In fact, I just finished work basically last week. Late last week. And I have been enjoying some time off, so it's been fantastic. I need to get back into it and get the guests back on here. But don't fear, I have got some subjects to talk about. I've actually enlisted the help of ChatGPT to give me 10 sort of like overarching bullet points that I can use to talk about. Because when I don't have anybody to bounce ideas off of, sometimes it's a little hard to organize myself. So I am not going to be using a pre-written script from ChatGPT because I think you folks listen for me and not for what ChatGPT has to say. So I'm only going to use the sort of overarching bullet points. So the prompt I gave it was, can you list 10 topics I can use for a podcast about electronics? And it said, certainly. Here are 10 topics you can explore for a podcast about electronics. Number 1, Introduction to Electronics, explaining the basic concepts, components, and principles of electronics for beginners. Well, that topic alone could take up the entire podcast to explain. So I'm just going to trim it down a little bit, and maybe I'll talk to you about how I plan to move forward with the channel now that I have more time. You see, I've got quite a few products here to review, which are good because those are videos I can knock out very quickly. But one thing that I really am passionate about is sharing knowledge. And I may not know everything about electronics and stuff that beginners do need to buy or to know in order to get started in electronics, but I definitely know some stuff, and I would really like to share that stuff. Now, maybe you guys remember one of the podcasts with another maker where I pledged to do 12 tutorial type articles with videos attached to them. Well, I definitely want to delve into beginnery type stuff. Now, that means basic beginner theory, basic beginner component use, and basic beginner type projects to get started with. And so I should have those articles started very shortly. I'm actually working on one as we speak, talking about the difference between batteries and cells and how to arrange cells into batteries if you need more current, more capacity, or more voltage. Because some of you might know that something like a AA, like a AA battery cell, well, that's actually just a cell. It's not a battery. A battery has to be, a combination of cells hooked up together. Well, if you have one of those cells, you have 1.5 volts. And if that's not enough voltage to run, let's say, a microcontroller, you have to add another cell in series. The two voltages will add up, one plus the other, and then you'll have a cell, or you'll have a battery, in fact, that'll be 3 volts total. Now, that one battery will last as long as that one cell powering your device. What happens is the capacity doesn't increase, but the voltage increased. So now, if you have not enough capacity, you have to take another 2 of those cells and put them in parallel with your first 2 cells. And then you effectively double the capacity and the current handling capabilities and keep the same voltage. So if you look inside, let's say, a multimeter, and there's 3 AA batteries, those are typically in series. Actually, they are almost entirely certainly in series to bring up the voltage to 4.5 volts. And so they don't last particularly long. I mean, it's a multimeter. It doesn't draw a lot of current, but the deal is that the voltage is high enough to, provide the power necessary for the electronics on the inside. Now, if you have something that's powered by a motor, for example, you could put, cells in parallel so that you have more, longer life on those devices. They'll last longer. So electric cars are a perfect example of this. They actually have quite a few cells in parallel to provide the capacity, so you get a lot of distance. So that's kind of like the deal. So I'm working on a video and an article about speccing out batteries, cells and batteries for your electronics projects. And so hopefully I'll get that done within the next week or so before I start my new contract. So if you have any subjects that you want me to tackle first, and it won't be anything like complicated, it has to be kind of simple to start with, just let me know in whatever, comments section that you can find on this podcast. And I'll try to address them. The stuff that has the most sort of demand will have the highest priority. So let me know, if there's subjects you want me to tackle first. All right, what did ChatGPT come up with for number 2? Number 2 is circuit design and analysis, exploring the process of designing and analyzing electronic circuits, including circuit diagrams, components, and circuit simulation software. Well, now that's kind of a broad topic, but circuit design and analysis, especially the analysis side, is not something I'm particularly good at. Someone like Big Clive is incredibly good at doing that, but make no mistake, it takes quite a while to sort of explore the circuits in consumer products. I mean, you got to tear it apart, and then you've got to follow every single trace on the PCBs and then redraw the circuit probably a couple times, especially when you're not used to it. And then, have the analyze the circuit, how it works, and then, pick up commonalities and then be able to re-explain that in a simplistic way for people to understand. Big Clive is an expert at this. He does a really good job. If I were to do it, it would take me hours and hours and hours more to produce videos, the way he does. And so I'm not particularly well suited for that. However, the circuit design process is something that I could probably talk about a little bit more, about how I sort of go about figuring out how I'm going to design circuits for like PCBs that I make, for example. A big thing that I do is imitation. I actually love imitation. I will get a little module from eBay or whatever, and then take a look at the components that are used on it so that I can get those components myself and integrate the design into my PCBs. So one of the examples that I have of that is I have a PCB to control 4 relays. And the relay drive circuitry on that PCB is actually pretty much ripped off from one of those sort of single channel relay driving modules, with a couple of differences. The relay driving modules, they have an optocoupler on there to separate the high voltage spikes of the of the coil opening and closing. When you cut current to the coil on a relay, it sends high voltage back the other way, and then you need a diode to quell that. But they use optocouplers in a lot of those circuits to make sure that it never goes back to your microcontroller. I decided to get rid of the optocoupler and just use a 2N3904 transistor, because the goal of my PCBs is often to just make it a little bit more accessible to people who might be watching, to you folks who are probably listening to this podcast. I would love for you guys to go on whatever PCB website that you want. I mean, I prefer PCBWay because they support me. It'd be nice if you supported them back, but it's not entirely necessary because I provide the design files and you can send them wherever you want. But I'd like for you to, order the PCBs and then build them up out of parts that you have in your junk bin. And the 2N3904 NPN transistor is pretty much in every electronics enthusiast's junk bin already. And even if it's not, I mean, you can salvage it from like an old VCR or whatever PCB you kind of have on hand. So the design is actually just a diode, a transistor, 3 resistors, an LED, and then the relay itself. And I believe that my thoughts of making it simple with jelly bean parts means that my designs are more accessible to the general watcher and don't require too many fancy parts. Let me tell you, there's a cool, I don't know if they're a company or a startup called Input Labs. I don't know if they're even like incorporated or anything, but they have an open source game controller that they're working on. And it's a shame because the idea is fantastic. I love the idea of 3D printing your own game controller, but it uses fairly expensive components to put the board together. And so it's a little bit disappointing that we can't do it, you can't make it with much cheaper parts. Now, there's probably a reason why they're using more expensive parts, right? It's probably more reliable. It's probably more of a polished, finished product. And so I've committed to building one of their game controllers as designed, and then propose my own changes to it to make it much cheaper, much more accessible, and preferably hand solderable, because at the moment their project is not hand solderable. You have to. Their recommendation is that you order PCBA, that you order the PCBs with the surface mount components pre-soldered, because some of them are like BGAs. They have solder balls underneath, so you cannot hand solder them. They have to be reflowed. And then you do the rest, the through-hole components by hand. And like, I don't disagree with their thoughts. Like, I think they have good ideas, but there's no way that there isn't an alternative to have a slightly worse product, because their product seems to be pretty good, but a more accessible product. And that's my goal. So I'm going to build one of theirs as is. I already have the parts here from LCSC. And then I'm going to try to make it a little bit more beginner friendly. So maybe somebody like a high schooler can take my modifications of their project and do that, for a high school project. They can put it together, or they can design their own pieces, and they'll have a base that's more accessible. I visited a high school a couple years ago now to check out their shop class, and they were telling me that they're not allowed to solder because it's too dangerous and there's fumes and whatever liability, et cetera, et cetera. But that's kind of frustrating, right? So maybe if it was through hole, then maybe the teacher could solder a couple of joints, right? But I mean, to use a hot plate and paste, forget it. So yeah, just a thought that I prefer to maybe have these projects, a little bit more beginner friendly. Before we go on with the next ChatGPT subject, I just want to talk about the sponsor of this episode, PCBWay. Again, I could put in the pre-canned, pre-recorded thing that I made, but I'll just, sort of speak from the heart. If you have a PCB project, or if you have a breadboard project you want to turn into a PCB, I would highly suggest that you do it. The satisfaction I got from soldering parts onto a PCB was incredible. And it continues to be incredible every single time I do it. And the thing is, with companies like PCBWay, it's $5 for a board that's smaller than 10 centimeters by 10 centimeters. But what I don't hear on a lot of these ads that you get for PCB companies that I like to say is that when you have smaller boards, you can actually order more than the 10 boards you get. You just increase the quantity until you get to a point where the price goes up, and then, knock it back down. And so if you have really small boards, sometimes you can get 20 boards or 30 boards for the same price, right? $5. And then the shipping, if you're patient, the shipping is only like, between $10 and $15 to Canada here. So we've got somewhere, $15 to $20 for, 20 boards, 20 small boards, or, 10 bigger boards, 10 by 10. So I would definitely recommend going to PCBWay.com or using the link in my description to go check it out yourself. Do an order, and if you don't like it, then stop using it. But honestly, I have never been disappointed with their boards, and I would actually call them out if they sent me bad boards. The only times that they send me boards that have defects on them is when I actually get more than what I've ordered. So I've got an order of 10 boards that came with 2 defects, but when you counted all the boards that I had, it was 12 boards. So basically I had 2 boards that I can practice on, which had defects they sent anyway, and then I had my full order of 10 boards. So check it out at the link in the description, and thank you very much for supporting me, PCBWay. All right, ChatGPT, what you got for us next? So number 3 is microcontrollers and Arduino, discussing the world of microcontrollers, their applications, programming languages, and projects using Arduino. Well, that's kind of a cop-out because I do use Arduino, Arduino clones for like 90% of my projects. But I do want to start getting more into the RP2040 boards. I did order a whole bunch of I don't remember what they're called. I think they're like the RP2040 stamps or something. They're like little, or RP2040 nanos, something like that. I don't know. They have an RP2040 chip, and they're very small. They're probably the size of a DigiSpark. They're a little bit more expensive than a DigiSpark, but the comparison is like not even fair. The DigiSpark is like $2. It has 6 pins, I think 6 usable pins, and it's 8-bit. It's doesn't have a lot of memory, but the tiny little RP2040 boards, they have the full 2 cores available, whole bunch of I/O. I mean, not all the I/O fits, but they have a bunch of I/O, and I believe they have auxiliary memory, if I'm not mistaken. So I've ordered a bunch. They're here actually. And so I do want to try to use them at some point soon because I find it really interesting that we keep getting these more and more powerful chips in these smaller and smaller sizes. And so you can actually do a lot more with them. Now, I don't know about like what someone like me can do with that kind of stuff. I'm not too well versed. I'm actually not like a big microcontroller genius, right? I just kind of like, bash snippets of code together until stuff works. But I do plan on getting better and better at programming as we go along. And especially the Arduino IDE is somewhere I'm very comfortable with. And so they support the RP2040. And so I don't see any reason why I wouldn't use it. Now, the only thing will be I tend to not code efficiently. And so that's a little bit better to use an RP2040 for that because it has a lot more frequency. So it does more calculations per second. It has more memory. It has more power. But at the same time, maybe I could, run into problems where I'm going to run out of I/O because of the fact that the little tiny boards don't have as much I/O. I don't know. We'll see if anyone has a favorite YouTuber that they turn to for their RP2040 stuff or the ESP32 stuff. Maybe like someone like Sion, the Unexpected Maker. Let me know because I want to follow some tutorials and get a little bit more comfortable with the RP2040 chips. They seem very cool, and in fact, the Input Labs controller that I was talking about, I believe they use an RP2040. I think they use actually the Raspberry Pi Pico board, the actual OEM one from the Raspberry Pi Foundation to do all the controls, because I think it does HID and all sorts of things like that. So yeah, let me know if you guys have a favorite source for that, because that'd be pretty good to know. All right, moving swiftly along to number 4. Internet of Things, IoT, exploring the intersection of electronics and the internet, discussing smart devices, home automation, and the future of IoT. Well, I don't know much about the future of IoT, so I'm probably not the right authority for that one. But I can tell you what I plan on doing. So I have a Node-RED instance running on Raspberry Pi on my network here. And I did promise another maker that I would try to use it for something. Now, I feel like I just missed my chance because we have the wildfires here in Ontario, which meant the air quality was very poor. And I do have some air quality sensors kicking around here. So I could have logged the air quality, I could have actually logged the air quality, but I ended up not because I was so incredibly busy. So that could have been a nice thing for Node-RED, but some sort of weather station or something like that seems like a great starting project. That or even controlling my lights, because I did build the relay board, the 4 relay board, to control my lights down here because, let me share you my first world problem. So I have absolutely horrible night vision. Basically, anytime that it's a little bit, shadowy, I can't see anything. I'm like freaking blind. On the highway, when someone is heading towards me, like let's say 2-lane highway, and they have their high beams on, I am done for. I have to focus real hard on the white line to the right of me in order to stay on the road. My eyes react very poorly to light changes. So when I come down to my workshop here, I have to flip on the light, right at the base of the stairs pretty much, then walk the length of my workshop, turn on the studio lights, the high CRI lights that I use as ambient lighting in my studio, and then walk all the way back and turn off the lights that I had turned on in the first place. The goal with the relay set is going to be to automatically detect my presence and turn on a portion of the studio lights, just a part to light up sort of like the background to give me enough vision so I don't crash into things. And then when I'm ready to film, it has 3 more channels. So I can turn on, the over workbench lights. I can turn on the studio lights, like the big overheads and stuff like that. So I'm hoping to get that accomplished. And I was just going to do it really on a microcontroller locally. But since I've planned for that microcontroller to be ESP32, that means I can probably integrate it into Node-RED and have Node-RED do the logic. You see, presence detection, like detecting that someone is there and still there, is actually not trivial. You'll get a bunch of accidental triggering. Either it'll think that someone's there, but it's just because a wave bounced up, up the stairs, for example, and then back down. Or it'll forget that you're there because it'll readapt, to your presence. It readapts every once in a while. And so those a little bit more complicated algorithms to figure out, if someone is there or not might be something easier handled by a Raspberry Pi than an ESP32 or ESP8266 or whatever it may be. So that's one idea. What's also nice is that Node-RED can combine a whole bunch of inputs, right? So I could potentially do like a laser trigger, basically like a light sensor, to see if someone crosses the threshold, and then I can put it into sort of an occupied mode and then cross it again unoccupied. You can actually have multiple triggers. So if you trigger A, then B, then C, then that means you're definitely walking in the room. If you trigger C, B, and then A, it means you've definitely walked out of the room. And I think those things would be a little bit more interesting on Node-RED. And so since I have to use Node-RED anyways, that might be the goal. So yeah, Node-RED, what do you guys think? All right, number 5. So we're moving actually quite swiftly along here. All right. Number 5 is consumer electronics, reviewing and discussing the latest gadgets and consumer electronics products such as smartphones, laptops, and wearable devices. Oh boy. What a good one. Well, should I tell you about the upcoming reviews? I guess I could, as long as I actually get to it as soon as possible. So, the first thing is M5 Stack reached out and they sent me some Stamp C3Us, which look like they are ESP32C3FH4. I don't know. They're like these tiny little boards with an ESP32 on board. Let's see if I can find some specs. It has 5 volt to 3 volt DC-DC design, 14 GPIOs, USB Type-C. They have an RGB LED reset button, an antenna. Yeah, not a lot of information on that. Specs, 384 kilobytes ROM, 400 kilobytes SRAM, 8 kilobyte RTC SRAM. Has Wi-Fi. Yeah, I mean, it looks really cool. I don't know if you know a lot about M5 Stack, but they make really cool products, which is pretty neat. And the other one is the Atom S3, which, let's see, what does it say? So it has an ESP32 S3 FN8. So I think the ESP32 S3 is special in some kind. And I don't remember exactly why, but I do know it's special. It has a 3-axis gyro with accelerometer, which is a MPU 6886. Has a 0.85-inch LCD. Oh, that is going to be actually quite interesting. IR LED, expandable pins. That's pretty neat. What else do we know about it? Yeah, pretty cool. I'm gonna try it out. Hopefully they have a demo project because I'm kind of naff at coding, so it looks like they do have examples. Pretty neat. So yeah, that is basically, it's here now, so that won't be too long. Next thing is that a Dawnstar, they're basically a microscope company. They sent me the AD409 Pro ES, which is basically one of the microscopes that have a screen built in. I believe it's a 7-inch screen. It's a giant screen. And what's really cool about it is it has an additional microscope built in for way more magnification. I've recently fallen in love with these kinds of microscopes because they have batteries and they have a base. So you just need to make sure they're charged, which honestly, they stay charged for quite a while. And then you just flip it on and use it when you need it. You can record with it, take screenshots, all sorts of cool stuff like that. So that microscope was sent to me and I have it here, which will be pretty neat. Pretty neat to review. I think microscopes are one of those things where I've often wanted like a nice optical microscope, like a binocular type with a third opening so you can put a camera on it. But these screen microscopes have gotten so much better in recent years that I'm not sure if that's actually like necessary anymore. I don't know. I'm going to take a look at this one and yeah, see how it goes. So yeah, pretty interested in that. Also, I had Kaiweets, the company that makes a multimeter that I really enjoy using. They reached out and they've sent me a soldering station and some lead-free solder. Now, I warned them that the soldering station is what really interests me. The lead-free solder, I was really not interested in. And the reason for that is that honestly, I don't like lead-free solder. You have to be a lot better at soldering. You have to be like, sort of on your game in order to produce a really good solder joint with lead-free solder. And honestly, I don't really feel like hassling, but I said I would take a look at it anyways and see what we come up with. And so yeah, they sent me the soldering station and the solder. So we're going to see how that goes. The soldering station, as with every other Kaiweets product, is fairly inexpensive, but it has some cool features that, other soldering stations in its price range don't have. And this one has like a magnifying glass and helping hands on a removable base that you can drop your soldering station on top of. And it looks like the top of the soldering station is protected against, solder drips. So it seems like you can sort of have this compact workspace with a heavy base because the soldering station sits on top and solder comfortably. So I can't wait to see how well that works in actuality. And give you guys my impressions on it. Kaiweets so far hasn't let me down. So yeah, pretty interested on how that's going to go. All right, what else are we up to? Number 6, embedded systems. Exploring the field of embedded systems, including hardware design, firmware development, and real-world applications. Oh, I don't know if I have much to say about embedded systems. I mean, maybe I can ask it for examples. I'll ask ChatGPT, can you give me examples of embedded systems that I can talk about? And let's see what it spits out. Okay. Oh, geez. Wow. Holy crap. Okay. It thought I meant 10 things again. So it's talking about home automation, automotive electronics. It says engine management systems for automotive is embedded. Is that true? Infotainment systems, that I can understand, more embedded. Well, I'll tell you, automotive electronics here. I'll talk about automotive electronics for my embedded systems. So automotive electronics is the reason I am into electronics right now and talking to you right now. Typically, when something goes wrong in a car, you typically have like a troubleshooting tree that the manufacturer would like you to follow. I worked for Honda for a very long time. Not for Honda, at a Honda dealership, which is not owned by Honda. People think they are, but they're not. They're independent. But anyways, Honda wanted us to sort of follow the diagnostic trouble tree, going from one step to the other. When it came time for diagnosing a bad computer, or a bad, a bad computer, they would not tell us what the expected inputs or outputs was. They would say, check the wiring going to the sensor. And if the wiring is good, check the sensor. If the sensor is good and the wiring is good, replace the computer. If that didn't fix the problem, replace the next computer. So let's say I had a problem with an ABS sensor. Okay, so anti-lock brakes. Well, if we tested the wires going to and from the sensor, that was good. And then we tested the sensor, that was good. And we tested the magnetic pickup on the wheel, that was good. They said then replace the ABS computer. And if that doesn't fix it, then replace the PCM, the main, PGMFI computer, the main engine computer. And so basically we would replace, a $2,000 ABS computer. And if that didn't solve it, we had to replace then a $2,000 engine computer. But instead of that, how about you just tell me what the required behavior is from computer A or computer B, so I can just test it directly and not tell my customer you need this $2,000 part with $100 in labor, And if that doesn't fix it, which there is a chance, then you have to spend $200 extra with another $200 in labor for this other computer and reprogramming everything. That didn't make sense to me. So that's how I set out onto the world of electronics. I needed to know more. I wanted to know how those things worked, how those magical boxes, as my students tend to think of them as, how it worked, and then I can do my own research on what's going on. Come to find out, it could be, lots of things internally, but typically we can't even repair them, because once you get inside, you need sort of automotive grade components to use to repair them. And I'm guessing most of the problems were down to multi-layer ceramic capacitors just shearing off or whatever, getting micro fractures. So it's actually quite interesting, the fact that these things don't work. Sometimes they just stop working, and we have no recourse. We just have to tell a customer the diagnostic trouble tree shows replace computer, which, it's silly. I hated it. And so, yeah, that's why I embarked into learning electronics, so I wouldn't be sort of like a slave to the trouble tree. So there. We're going to cut the embedded systems chat a little bit short because, I don't have much to say about it. I do hope to one day be a little bit better at these kinds of things and get into it. But until then, we'll skip on to number 7. Number 7 is robotics and automation, discussing the role of electronics and robotics in automation. Well, thanks, ChatGPT. Covering topics such as sensors, actuators, and autonomous systems. Well, I feel like I haven't done a lot of robotics on my channel. And the reason for that is that I'm not great at coding. So maybe when coding becomes a little bit easier, robotics will become a little bit easier. But what I do like about robotics is that you can boil down sort of a lot of the fun stuff to do in electronics. When you boil down robotics, you get into the fun stuff to do in electronics. That's what I meant to say. Like, for example, a robot typically will need a drive system. And usually those drive systems are one of two things, maybe three things. So you've got electric motors, you've got like DC motors or either DC or brushless motors. Then you've got DC brushless motors, stepper motors, I can even say. Then you've got servos. Servos are basically just motors with feedback, positional feedback. And then you got linear actuators. And like those are the major three categories. But all three of those are types of motors. And so if you learn to just drive motors, you get access to all of these things already. Then if you learn how to do analog inputs, so like grabbing inputs from a potentiometer, for example, then you've got, your drive capability and your positional feedback. And then if you do that over multiple joints, then you end up with something like a claw, like a robot arm. I find robotics and automation projects super cool. I'm trying to get, I want to make sure I get his name right. I think it's RC Test Flight. He is a YouTuber who is in Seattle, and he does autonomous RC boats and planes and stuff like that. And robotics and autonomous RC stuff is just kind of like hand in hand, pretty much the same thing. And I find that really cool. I'd love to really get into that. Maybe I should look into like a controller like he has. Because basically you get like a flight controller, which is not necessarily just for flight, which drives motors directly and has GPS signals. And it just picks up GPS positioning and you make waypoint missions. It seems really freaking cool. And just thinking about it makes me want to get into it. So maybe I'll add that to the bucket list. I'll have to take a look at what I need. What's the minimum I need to have fun like that? Because, that seems like a lot of fun. All right. Skipping right along because it is getting late. At the time of recording, we are 10 p.m. on June 20th. So I really need to get this thing edited and out. Number 8, renewable energy and electronics, focusing on the integration of electronics in renewable energy systems, discussing solar panels, wind turbines, and energy storage. Well, thank you for asking, actually, because my batteries, the most expensive item I have ever bought for the YouTube channel, they are in my hands. I can't even contain the excitement to have them in. Now, it's not all puppies and rainbows. I mean, they were supposed to be grade A premium cells, but it doesn't even look like they're all from the same batch. Some of them, where the laser welding is for the terminals, looks really nasty, as if it burned some of the material away. Some of the QR codes that is laser etched onto the case doesn't seem like it's the same as the other ones. The storage voltages are not all the same. I don't know. I'm not being negative. I'm still being positive because I didn't pay that much compared to what these things have been costing for a very long time. So I'm still excited, and they'll still work well enough, even if I don't get 100% of their capacity out of them. They will still work well enough to do the experiments I want to do with them and to replace those massively heavy 12-volt lead-acid batteries that I have, because it's ridiculous to haul those things around. It's like absolutely insane. So I'm still thrilled to have them, but it's definitely not, the AliExpress seller is definitely not being honest, which I sort of thought would be a possibility. Some of them are a little bit puffy too, which is, again, if you look a lot into these sellers and people buying batteries and stuff like that, it is an occurrence. It does happen. It doesn't mean the cells are junk. But anyways, I am excited to jump in on this trend of lithium iron phosphate batteries, and so I'm all in. Now I've got 3 different BMSs to try, and boy, do I ever have stories to tell about the process of sourcing and ordering lithium batteries and BMSs and how much the BMSs cost. Holy crap, they cost a lot of money. I think with the 3 BMSs together, I could have probably ordered another 4 or 8 cells. All this stuff is expensive, but I'm, I guess the British would say I'm chuffed to bits. I can't wait to get started. I think that the views might be cool, but aside from that, I really wanted the experience of building these battery packs, and so that's what I'm going to do. On top of that, I still haven't gone and positioned solar panels in my backyard, so that's another thing I need to do, which I will do, and I'll be pretty thrilled to do. And so, yeah, I can't wait to get all this stuff started. I have this, I have another 6 days off or so, more like 5 days off. And so I can't wait to get started with all this. So if you guys are as excited as me, get subscribed to the YouTube channel, or just, listen to my excitement whenever I talk to a new guest on the next podcast. Either way, I'm thrilled. And so if you're happy, then I'm. All right, number 9. Ooh, we're almost done. Ooh, the episode's going to be a little bit short. We'll see. So number 9 is 3D printing and electronics, exploring the intersection of 3D printing and electronics. Thanks. Like it says, subject, and then exploring the intersection of subject and electronics. Thanks. Discussing projects, materials, and techniques. Well, I don't have any updates, I don't think, on any of that. I do know that we're going to have some rainy days coming up, and so it might be perfect days to work on the Tronxy X5 SA, big cubic sort of 3D printer that I'm going to upgrade to linear rails and flash new firmware and use a new controller or something on it. So that's going to be pretty cool, but I mean, that's going to be a long-term project. I need to get myself a reliable printer out of it. So hopefully with, the only thing staying intact being the frame. Hopefully that means that the 3D printer will become really reliable. I do not recommend Tronxy products to anybody. I've reached out to them to see if maybe they can offer some sort of brand new Tronxy, and if I put it together myself, maybe it'll be better, because my X3A, which I put together myself, actually ended up being decently reliable. But yeah, I don't know. I'm not a big fan of what I've seen, but the previous owner of my X5SA didn't seem to know what he was doing. So maybe there's that. I don't know. I can't wait to upgrade it and see if I can turn it into something reliable. I've got all the parts here. Most of the parts are 3D printed, and then I've got some linear rails. I'm going to upgrade the hot end to all metal. It should be pretty neat once it's done. And then, yeah, I can run some printing projects, especially when it's not so hot anymore, because then the heater won't be fighting my AC. You know, I'm trying to cool down the house, and then this thing is like a, you know, heated bed and heated hot end, trying to warm up the house. But, you know, whatever. The cool part about this stuff too is that hopefully I'll be able to charge up the lithium iron phosphate batteries during the day and then print for free at night. Or even, let's say, day one, charge the batteries to full, and then night one, you know, we do nothing. But then day two, right before sunup, if I start a print and I let the solar panels charge the batteries while it prints, then it might be completely free. Like, you know, these kinds of things really intrigue me. Can you run a 3D printer directly from lithium iron phosphate batteries, which are being charged by the sun at the moment? How sensitive are the electronics to fluctuating voltages? You know, how is it, you know, when you, if your solar panels pump too much current in, your hotbed won't be able to draw down the batteries enough, and so you end up where the BMS cuts off the pack completely to save from an overcharge. And at that point, because it cuts off, then it shuts down your 3D print, and then, you know, you lose all your progress. These kinds of things intrigue me. This is the kind of stuff that I want to play with, and I'm excited to play with. So yeah, that's 3D printing right there. All right. Number 10, almost done this marathon of ChatGPT-ness. Emerging technologies, discussing cutting-edge technologies and trends in the field of electronics such as artificial intelligence, virtual reality, and quantum computing. Wow, I know nothing of these. Okay, I have used 9 out of your 10 prompts. Can you give me one last easy electronics subject to talk about in my podcast? Please. I'm going to be nice to ChatGPT because it's our robot overlord. Electronic components and their functions. Discuss the fundamental electronic components such as resistors, capacitors, inductors, diodes, transistors, and integrated circuits. Explain their basic functions, symbols, and how they're used in electronic circuits. You can touch upon topics like passive versus active components, common component packages, and the importance of component selection. Ooh, okay, that's a nice subject, but difficult to discuss on a audio only podcast. I don't want to misspell because I don't want it to think that I don't know what I'm talking about. Audio only podcast. Can you suggest a different topic, please? Here it goes. Apologies for the inconvenience. Oh, you don't have to apologize. Troubleshooting common electronics issues. Focus on common problems that people encounter with electronic devices and provide troubleshooting tips and techniques. Discuss issues like power supply problems, electronic circuit board faults, component failures, and signal integrity issues. Offer practical advice on how to identify and resolve these issues, including using multimeters, oscilloscopes, other diagnostic tools. Yeah. So I think ChatGPT is onto something there. The big thing, I think Dave Jones has coined this phrase, thou shalt check voltages. So just with the basic use of a multimeter, go around and make sure your board has power. If it's a device that's plugged into the wall, be extremely careful on how you handle your probes. Do not touch more than one contact point at a time. Do not let your probes touch each other. But you definitely want to check if the traces are good coming from the power in and the ground or the power out, whether it be AC. You definitely want to check if you're getting power past your fuses. A lot of consumer electronics are made, rightfully so, with a fuse right at the input. And sometimes mechanical vibrations or inrush currents or stuff like that can cause those fuses to blow. And so make sure you're getting voltage past the fuse. It's so common that things you find in the trash, like, appliances, like maybe not like maybe a microwave, or maybe not a microwave, but like a stereo, for example, very common. You open a stereo or a home theater sound system, and inside are two glass fuses, and one of them are blown. And so the unit turns on, but you get no sound because the main logic board fuse is okay, but the amplifier fuse is blown. And so all you have to do is replace the fuse and you're good to go. If you're working on like a DC type circuit, again, make sure your voltages are right. Most DC circuits, most even AC circuits will run at a certain voltage to the power supply, and then they'll use regulators to drop down the voltages. Make sure those regulators are supplying voltages, especially near microcontrollers. You'll often find like a 3.3 volt linear regulator. Well, you need to make sure that 3.3 volt linear regulator is still supplying its 3.3 volts. Another thing you can do is find those regulated rails and set your multimeter to AC volts and see if you're getting an AC ripple. Like if your voltage is not solid, if it has like big variations, like oscillations on it, it can cause chips to constantly brown out. And so you want to set your multimeter to AC volts, and on a DC rail, in a perfect world, you'll have 0 AC volts. But in an imperfect world with worn out or dried capacitors, then for sure you're going to see some AC ripple in there, and that's not a good thing. Very likely your capacitors have failed, or maybe your power supply is shorting and then current limiting to 0, and then resetting, and then shorting, current limiting. Definitely have a look. Another thing I just touched on real quick is capacitors. Electrolytic capacitors, they get hot, they dry out. Sometimes they spew their insides. So if you see any bulging in their case, it probably needs to be replaced. But I'll be honest, capacitors are kind of a pain in the butt to test, because a real test of a capacitor will have you removing them from the board. You can't really test them in situ. I mean, you can try, but it's not a reliable test. So yeah, capacitors, take a look at that. Another technique I tend to like is to turn on the device and either use a thermal camera or a thermocouple or just your hand and touch around the board to see if one component's getting overly hot. If a component's getting overly hot, it's probable that it or something near it is failing, causing too much current to flow, or causing, another component is causing too much current to flow through it. And so typically you're going to see it as a hotspot when there's a lot of current flowing. So that's a good idea to check as well. And then I guess the other thing is that especially in a high vibration environment, solder tends to crack. And so a nice, microscope with a nice screen or, nice binoculars on them, that will give you an idea if like a leg of a chip is not well bonded to the board or stuff like that. So visuals, voltages, capacitors, fuses, check the usual suspects first. Definitely. Because, there's no sense in chasing ghosts if you don't have to. So hopefully those were decent tips. And hopefully you've enjoyed this ChatGPT powered episode this time. I just figured instead of me generating my own topics, I do have a lot of things on top of my head, but sometimes it's really hard to think of, the actual topics. So I figured ChatGPT would give me a hand this time. And if you guys like it, maybe this can be a reoccurring segment where we just ask ChatGPT to select something, and then I can just go off with whatever knowledge I do have. I do feel quite flattered, though, that some of you give me a lot more credit than credit is due. I often get emails from people asking me how to solve X, Y, and Z problems. In fact, recently, I had someone reach out. They wanted me to be their electronics tutor. And I said, well, the thing is, I think I have a decent base knowledge of electronics, but only really a base knowledge, not really a full comprehensive, I'm not an electronics engineer like Gadget Reboot is, or like Dave Jones is. I really am more deep in the hobbyist realm. And when people, want me to tutor them, I'm fine with that. I can teach basics. I can teach, putting components together, how breadboard works, how multimeter works, all these things. I've got this, got it on lock. But things like, how do you bias an op amp? How do you make split rail power supplies? And how do you, make sure things are stable? It's like, this is way out of my wheelhouse. And I do appreciate you guys thinking that I'm really good at it. Or even worse than that, when people message me or email me and they want software advice. And I'm like, man, if you're asking me for software advice, that's because you have not been paying attention to my channel. I'm not Mr. Software. So I am flattered when folks reach out and ask me questions like this. But you guys should know that it's not a good idea if you want accurate results. Because, yeah, I am far from a software genius. I could refer you to software geniuses if you guys want, but it ain't me, basically. I'm not the fortunate son, as CCR would say. But yeah, I do appreciate everyone tuning in every week. Like I said, it warms my heart that I have actually hundreds of weekly listeners at this point. I never thought I would have 100, but I have hundreds, which is awesome to know. And I'm really glad that some of you look forward to the episode every week, because on days like today, where I was like, oh, I forgot to reach out to a guest again, I feel quite happy that you guys are listening, and it gives me the encouragement I need to get off my butt and record the episode. So a little bit shorter one today, but that's what happens when I talk to myself. But I am getting back on the video train. On the live streaming channel today, I got on, filmed a mailbag video, said hello to my regulars that go on to the live stream channel. Link on the description. And so I'm getting back into filming stuff. I have some sponsored content coming, which needs to get done because I need to recoup my costs for the batteries. And, maybe a little bit of off-topic stuff for those of you who listen all the way to the end. So when I was a kid, there is going to be a video on this too, so don't worry about it. When I was a kid, I was into Legos. Let's say, I mean, I was born in 88, so you can think 95, 96, that kind of, those kinds of years, 97 maybe. I was into Legos, and I thought that my parents had got me the coolest Lego set I have ever seen. So it was, I think it's called the Shuttle Transcon. So basically, it's the NASA space shuttle, but it also comes with like an airplane, and you clip the shuttle to the airplane, and that's how they used to transport the shuttle across the U.S. is they used to, mount it on the top of an airplane and fly it around. So they made a Lego set of that. The amount of detail is staggering in that set. It comes like the shuttle bay opens. There's a Canada arm. The Canada arm, for those of you that don't know, is a robotic arm that they use to launch, attachments to the ISS and stuff like that. But it was a Canadian funded and built thing, so they call it the Canada arm. And so this thing has a Canada arm, has a satellite. It even has like one of those tow vehicles to pull the airplane on the tarmac and stuff. Anyways, coolest set ever. Every once in a while, I checked on eBay for it because I'd really love to have it. I mean, it's probably, I had a lot of Legos. They're in boxes at my parents' house, but all in a big, mishmash, and very likely a lot of parts are missing. Like I'm guessing like a lot of parts. So I look on eBay from time to time, and I just dream, I'm just looking at it. Usually people want between 150 and 250 Canadian dollars for a complete set. And because it is vintage, it came out in 1995. And it's Legos. Legos typically don't go down in value; they go up. So, yeah, I was just dreaming one day. Maybe I'll find my Legos I'll go get my Legos at my parents' house, and I'll go through all the parts, and maybe I'll be able to build most of it back up, and then I'll just buy the Lego parts I need to complete it. Yada yada, whatever. But then I saw recently a Canadian seller. Usually Canadian seller means cheaper shipping, because even though shipping is expensive in Canada, it's cheaper within Canada than from the US to Canada. So Canadian seller who had one, already way cheaper than the ones I kept seeing. So I think he was asking $80. I think it was $80 he was asking, plus $20 of shipping. That's still $100 for a piece of nostalgia. That it's too much. It's too rich for my blood, right? But he did have a or best offer, so I lowballed them shamelessly, right? It's a complete set, no box, but it did come with the instructions, and some of the decals were they're peeling, and it's an old set, right? It's yellow. Some of the parts have yellowed. It's fine. It's an old set. And so I lowballed them because I do want it for nostalgia, but I don't want to pay a lot of money for it. I don't have a lot of money to throw around, right? I would argue the batteries are, a business decision. But he agreed. He agreed, and he sent it to me, and it's the coolest freaking thing ever. It came partially disassembled, so basically he just ripped apart pieces to make it fit in the box. So I have a video of me unboxing it, of me putting it together, and I can't wait to edit that up and toss it up on the channel and see what you guys think of it. I love Legos. I've been lusting for the Saturn V Lego, the new one, the 1963 piece one. But again, really expensive. It's over $200. It's brand new, but still, it's over $200. So yeah, now I have the Shuttle Transcon. I'm super happy, and you guys will get to see it in a video. I will put it up on a shelf somewhere around here, because every time I see it, it makes me happy. And yeah, that's the goal. So yeah, I have that, which I am so thrilled about. So yeah, hopefully you guys are going to like reliving my nostalgia stuff. And in other news, I did some fishing. So I did spend some time on the water, which is both good and bad. It's good because I love being on the water, but it's bad because I should be using my time off to be working on my YouTube stuff. But anyways, I'm doing that now. So there we go. So if you guys want to see videos, they are upcoming. Make sure you subscribe on Patreon if you want early access, because very likely what's going to happen is that I'm going to be filming a whole bunch in quick succession and then sort of releasing them slowly because I have time off now. But at the time you're listening to this, I only have a couple of days left off before I have to go back to working 5 days a week. And so videos will continue during that time, but they will not be as frequent. So very likely I'll have a little bit of a backlog built up on Patreon. So yeah, thanks everyone for listening. I'll catch you in the next episode. And yeah, make sure to leave me a comment on whatever platform you're listening to this on, if comments are allowed, because I would love to read them. Thanks for listening. Catch you on the next one.